hello, you are supposed to find the value of this complex integral along the contour C, and our contour you are given it is a circle. Our contour is a circle which is of radius 2. So first of all, we are going to identify the type of pose. We identify the pose by realizing that a pole is a point where the function is not defined. So we consider the denominator and we find the pose for z squared plus 1. We solve this quadratic equation and we find out that z can take two values. Z can be equal to plus or minus I. Then all these two poles are inside the circle of radius z is equal to 2. And now, as a result, now all of them are of under 1. So after identifying the poles, after finding out whether they are inside or outside and their order, then we apply what is called Cauchy integral formula for one factor. And first of all, we are going to get the sum of the residue. So we shall obtain the residue at the pole I, which is found by the limit as z tends to I of that complex number when it is z minus I divided by z minus I multiplied by z plus I. The denominator has been written in terms of its factors. It has been written in terms of its factors. Of course, this part here will cancel with this other one. And now we are going to be left with limit as z tends to I of course I pi z divided by z plus I. So where you have z, you substitute it with I. And when you do that, the numerator you are going to have I times I, so it will give you I squared. Denominator you have I plus I, which will give you I plus I, which will give you 2I. Now I squared is negative. Negative cos negative, it is the same as positive cos. So here we shall obtain cos pi over I2. Now negative cos pi is the same as positive cos pi because cos is an even function. So instead of writing negative cos pi, it is the same as cos pi divided by 2I. Then by Cauchy integral formula, along a contour for a single factor, then the solution is given as follows. You have 2 pi I, this is the formula, multiplied by the sum of the residue. Our residue you have found to be cos pi over 2I. This 2I and this one will cancel and you will be left with the pi cos pi. For z is equal to negative to positive I. Then you go to the second pole. At z is equal to I, this function is not defined. It is discontinuous. So we get the sum of the residue, limit as z tends to I of this function, whereby now this part will cancel with this, so that now you are left with the limit as z tends to negative I cos I pi z divided by z minus I, which is equal to cos. You substitute where you have z with I. The numerator you will have I times I will give you I squared. The denominator you will have negative I minus I, which will give you negative 2I. Then here negative, up there you have negative cos pi divided by negative 2I, which will combine to give you the numerator, the numerator, negative cos pi and cos pi is the same. So you come and substitute. You have 2 pi I multiplied by cos pi divided by negative 2i, which will give you negative 2i will cancel, and you will have the result will be negative pi cos pi for z is equal to I. Then the sum of the poles in this case will be 0, as we see here after adding. So that is how we evaluate a complex number using the Cauchy-Riemann integral in those simple method steps. So thanks so much for taking your time to study with me on how to evaluate the complex integral using Cauchy integral formula for a single variable. The steps are simple. First of all, you identify the poles. Once you identify the poles, find whether they are inside or outside. In case they are outside, then the sum of the residue will be 0. If they are inside now, identify the under. Then from there now, find the sum of the residue. After finding the sum of the residue, then apply the Cauchy-Riemann integral, and through that you are going to find your answer in those simple method steps. Then it is going to work for you. Thanks so much. See you in the next method as we keep on learning together.